So now let's consider the two-dimensional case. Here we have to bring in the idea of moments. A moment is describing the tendency to rotate. In this case, rotation around the y-axis. So a measure of the tendency to rotate around the y-axis, we'll denote that as m sub y. M stands for moment about the y-axis, and it is the sum of the masses times the x-coordinates. Because here's a two-dimensional system, here's our y-axis, and we've got a point out here at 5, 0. So if that's going to rotate around the y-axis, that's going to be a function of its distance from the y-axis, right? And that distance is given by the x-coordinate, 5 units from the y-axis. So that's why our moment's defined here as the sum of the masses times our x-coordinates. And then the moment about the x-axis, m sub x, is the sum of the masses times the y-coordinates. So then your centroid's defined, x-coordinate of your centroid, x bar, is defined to be the y moment divided by the total mass of the system. So sum of mass times x-coordinate over m gives x bar. And for y bar, it's the x moment divided by m. So sum of the masses times the y-coordinate divided by m. So let's put these guys to work here. So we want to find the center of mass of this two-dimensional system. We've got 4 weights on there, and we've got x and y coordinates here. So our x bar, we are going to sum up the masses times their x coordinates. So we've got a 2 gram mass here times x coordinate -2. And then a 1 gram times x coordinate 5. And then a 1 gram times x coordinate 0. And then a 1 gram times x coordinate 4. And then we are going to divide by the total mass, 2, 3, 4, 5. So that's going to be -4 plus 5 is 1, and 0, and 4. So 1 plus 4, 5 over 5, which is 1. So x-coordinate of the centroid's 1. For y bar, we sum up the masses times the y-coordinates. So 2 times 1 plus 1 times 0 plus 1 times -3, and then plus 1 gram times -4. And then divide by the total mass again of 5. So we've got 2 minus 3 is -1. And minus 4 is -5, so -5 over 5, which is -1. So our centroid here, x bar, y bar, is 1, -1. So 1, -1, right there is the balance point of this system. So if you think of taking a piece of plexiglass and putting 2 gram, 1 gram, 1 gram, 1 gram, putting the weights on at these coordinates, if you put your finger right at 1, -1, that's going to balance that piece of plexiglass. Pretty cool.